Hi, my name is Frank Larkin. I am the program delivery partner for PA East and Northern New Jersey with Mid-Atlantic Robotics. Today, what we're going to talk about is the update to the Spike Prime MAR toolkit that I introduced last season. This season's version will be for version 3.0. So this is the introductory presentation to this. This is also going to contain additional um, source material that we will talk about as we go through it. So let's get started. As the last time, this is a prepackaged, tested, and working Spike My Block tools for the FLL Challenge teams. I am not going to show you any missions that were done for the current season. I used last season's for my demonstrations. I hope teams will incorporate these into their robots to get a jump start on the season. You'll immediately be able to score more points because you'll be at least able to move. I have some well, I don't think they're that advanced, but I have some advanced learning concepts that will help you try new things on your own and learn what it means to have a gyro. So you'll be able to look at the math, look at the old materials, and you'll see it. This project will not show anybody any of the new missions in the current system. That's all up to you. Teams can use last season's field to test the demo code with their new robots, and let's see if they work. Teams are still going to have to build your own robot with your own plans from Lego or the internet. I use plans from BrickHub called the Super Powered Robot. This robot may or may not be good for the Masterpiece season, but it'll get you a quick start. And many thanks to them for providing that. If you follow that link, you'll actually go right to a thing that will tell you how to build it. And I built it, and it worked pretty well. You are going to have to change, and we'll talk about that in a minute, some of the where things get wired, but you'll hear about that. So you're still going to have to plan your missions, build your missions mechanical tools, and program them. Okay. However, the tools will help you do that a little quicker because it encapsulates a bunch of things. Understand, hopefully, you will be able to understand what you're doing and be able to explain it to the judges. And I think it would be helpful if you did a deep dive on how it works because it's actually pretty simple. And it's actually kind of cool once you understand it. My real hope, in the spirit of gracious professionalism, is that we want everyone who is inspired by these tools and have a great time. So the takeaway right away: coaches should, you must take some time to view the original materials to understand how they work. This includes several YouTube videos. There are going to be more YouTube videos that are specific to the 3.0 version. The 2.0 version has an extensive discussion about gyro and line following. And we also display the math. We talk about the math. I'm a big fan for if the math works, it should work. But it is really easy to understand. These are all available from our website, FLL Challenge Team Info and MAR Challenge Tools. And there'll be a whole section for things that you can pull. So when you're ready to go install these files, understand that the difference between the 2.0, the 2 system, and the 3.0 system is really the file extension. Your project is going to have a demo program designed to show the advanced gyro and distance navigation. And in it, you're going to have my blocks, which are the things that I've built. And then there'll be some code put together to do the demonstration. The Spike program file, Spike 3 demo 223 final.llsp3, that LLSP3 means it's Spike 3, is what you're going to want to get. To install these, this seems like it's kind of funky, but it does work. So you want to go into Spike 3 version of your code, create a project, and just put in a few entries. And then you're going to save it to Spike 3 demo 2023 final. Save it to your system. All right. Close the development environment. Now copy our file so it overwrites your version of the program. Just copy the file. It should have an LLSP3 extension, and then restart your environment. And then when you open the program, you'll have our demo code. Okay. If your robot has a basic design, you maybe will run our code on your robot. And and last year's supercharged field to test. If you want to do that, there's videos that show you, so maybe you don't even need to do that. If you have problems, there's going to be weekly, let's be frank, Zoom calls. If you have real problems, you can give me a call and I'll try to help you work it out. Now, when you're ready to start coding, we're going to give you a file that's going to be Spike 3.0 clean LLSP3. This is the version that's not going to have any of the demise files in it. You're going to want to use that code. Okay, that's the one you're going to want to use. And so what you would do when you're ready to create a new project, all you do is, as we did before, create a file, call it Spike 3.0 clean, or whatever file name I come up with, Spike 3.0 clean, save the program, close the environment, copy our copy of Spike 3.0 clean to yours, okay? And usually it's under the folder documents/Spike, and then restart the Spike 3.0 development, okay? Now, the way this would work is if somebody wanted to do, let's say, mission 1 on your system, you would load up the clean version, rename it, or save it as on your system, the new name you want to call it. Let's say it's mission 1, okay? And then that's what you're going to work on from then on. You don't want to save it over the Spike 3.0 clean file. Remember, you can always bring up another copy of Spike 3.0 clean. Now, you may find things that you're going to do on your version of clean and fix it up. What you may want to do is save that to your system, and maybe as a helper, put a 1 or a 2 or a 3 next to that file name when you save it. That way you know it's yours. But you always know that the Spike 3.0 clean is out there in case you want to start a new set of missions. All right, now we're going to talk about the updates. And I'm going to do a little bit of a deep dive here, so I want you to make sure that you understand what we're doing. So in this discussion, MB, capitalized, will mean MAR Brick Tool My Blocks. These are subroutines created using the Spike Prime Scratch code 3.0. Okay, it's a subroutine. All subroutines allow you to pass parameters, so you'll see that. It should be understood that the Spike Prime Lego robots are toys. They're not military-grade devices. So the My Blocks help get better accuracy if they use properly. Quite frankly, I've never used the direct tools because I felt it was important that if you had a tool like this, you would be able to see how actually understand, and your students would be actually able to understand how the gyro works and does the correction. With what we get from FIRST, we really don't see that. You just tell it, go follow this angle, and off it goes, okay? There are several short videos that have been created to demonstrate the demo, okay? There will be a playlist available on the YouTube channel, and you will be able to see those. All right, so let's talk about gyro accuracy. Anytime I have a name of a file, anything here that's highlighted, it's going to be a My Block. So there is a My Block called Gyro Turn to Angle My Block, and it has an accuracy of plus or minus a half a degree. Okay? So robot drift. What happens when the robot is moving? It may pull left or pull right as it runs. Okay? This may be because of mechanical issues, weight distribution, rubbing wheels, gears. The amount off of the desired angle we call underscore correction. Anytime you see a variable that uses underscore, it's something that's used by the code, and don't mess with it because it's going to be messing with it. So you don't want to do that. Okay? So that correction tells us, am I left or right of where I should be? Once driving, you may notice the robot will slightly wiggle as it moves. The code is in fact actively keeping the robot on the selected angle. There are a few variables that help us with this. The QA document explains all of these, but we're going to explain a couple of them here. Using this in demonstration shows the My Blocks actually had great repeatability. However, you must make sure the wheels are cleaned periodically so we can minimize wheel slip. Wheel slip is what the wheel turns, but we actually didn't go anywhere. Okay? And wheel slip affects the distance more than the angle. The angle is always going to get corrected, but the wheel slip is the thing that's going to affect distance. The robot should also be as fully charged as you can when you go out to do a run. That is because that can affect distance. I'm not sure why it affects it so much, but over time you can actually see it. Okay? Okay. So we have a my block called gyro turn to angle. Okay? Testing has shown that turning too fast with the gyro can eventually throw the gyro accuracy off. Okay. So if you imagine I'm pointed at 45 degrees and I want to go to minus 45 degrees, and if I didn't have anything in there, as soon as I hit it, the thing would fly over. And originally, when I started this, that's what was happening. And eventually, it would stop working. And I couldn't understand why. And eventually, I figured it out. It's because I was turning the gyro too fast. So to fix this problem, I created a my block called gyro turn to angle. And this my block turns at a specific slower speed called gyro turn speed max. Okay? You can see it there. It's set to 15. It also uses gyro turn speed min to set the lowest possible value your robot can use to turn. Okay? If you put too big a number there, it's going to constantly miss because it's going to overcorrect. But the number 3 or 2 or 1 helps and is pretty good. This helps slow turning, helps keep the gyro accurate. On a heavy or unbalanced robot, you may need to adjust these. Testing will tell. So what kind of things can you run into? The tires may be rubbing. You may have too much weight on the front. So you have to think about that. Software is not always going to correct these problems. You always have to, and I've been doing this for many years with big robots, and that's the God's honest truth. The hardware guys are thinking, oh, the software guys will fix it. The software's not going to fix it. It's got to be free to move, and then the software can nudge it as we're saying, and we'll do great. Okay. This my block was added to the original Spike 2 version when it was the turning fast problem was occurred, but it may not have been working fully. The 3.0 version works fine. In some of the gyro my blocks, this is added to turn the robot to a specific angle before we move forward or back. The robot will turn, and you'll see it in the demos. Once turned, the robot will reset the wheel encoders. Then the distance it travels is accurate. It's so accurate that you can actually draw out all of your missions on paper. And in fact, I would encourage you to do that. Draw it out on paper. First has a drawing which represents, and it's to the accurate size of the field. And you can use that, print out a bunch of them, have your kids sit there, measure it all out, and draw it. And we'll talk a little bit about how you might not want to do that. Okay. Now, the other thing is, once we start driving, as different from turning, this turning thing, testing has shown that the gyro accuracy degrades over time. At best, when driving, it is best to be pointed in the right direction before you start to move. We use the gyro turn to angle for that, okay? And you can call that directly at any time if you need, okay? We'll talk about some other things, and maybe we'll have a little bit of a discussion about that. While gyro driving, the code takes a reading of the gyro yaw value. This is the left to right angle. Negative means we've drifted left. Positive means we've drifted right. This then becomes the correction. We can modify that by multiplying by the adjust drive. 1, there's no change. -1 will flip the direction. This is if for some reason the motors are in wrong. You can try putting a -1 in adjust drive, and it will flip the direction of the motor. Okay, I hope you never have to use that, but I haven't really tested that, but that's in there for that reason. We use that on the big robots. We also modify it using adjust gyro. 1 equals no change because we multiply by adjust gyro. 2 means each degree off, adjust correction by correction equals 2 times underscore correction. 3, it would be 3 times underscore correction. It means we're going to use more power to try to correct us moving back to the right or the left. This will make for a more aggressive correction. This is envisioned if you have a heavy robot or again, it's dragging something. And it may change from mission to mission depending on what attachments you stick onto the robot. So test, 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 but it's there for that purpose. And you can change this anywhere you want in the code. Okay, so you can change it in one piece of your code and then reset it back to another thing, and then from then on, it's going to do gyro adjust just the way it always did before. All right, so play around with it and test it. Okay, now here are the big things that actually make it all work. Gyro turn to angle, and then it says angle. What that means is that we have a parameter called angle, okay? And you can then put a number in there, all right? If you see the ones below it, minus 45 means negative 45 angle, means 45 degrees to the left, okay? This is used to turn the robot to a specific angle before you move a distance. It uses the global variables, gyro turn speed min and gyro turn speed max to regulate the speed, right? We just talked about that. Then there's gyro drive by distance. Now, in this case, it's saying 40 is the speed, minus 45 is the angle, and 20 is the distance. This is used to drive a certain speed, plus or minus, at a certain angle for a certain distance. This will also call gyro turn to angle first to get the robot to the angle before it drives the distance. So it's very handy. It's doing three things: adjusting the angle, right? Driving at a certain speed, and then calculating the distance that's gone. And it is pretty accurate. Okay, gyro drive to waypoint line has a parameter for speed, which is 40, and 0, which is the angle. And this is used to drive at a certain speed and angle, but will stop when it crosses a waypoint. A waypoint is a line, a dark line, anything you like on the field that you can pick up with the sensor, the light sensor. And when you see the value there go up a certain amount or below a certain amount, you can say, stop, I've moved enough. This is helpful. If you look at the field, you'll see certain areas have a line sticking out the side. We call that a waypoint line. Okay? Last year, there were a lot of those. This year, I'm not so sure that there's going to be any. But you can experiment. These are grouped here together because neither one of them uses gyro turn to angle before they start. Okay? This is the same as the gyro drive to distance, but it will not first turn to the angle. If your robot is against an object, for example, it may not be able to turn to a new angle first, and it'll get stuck. So imagine you're pushed up against the wall, you try to turn, the robot tries to turn, and it's stuck. And this does happen. This will try to turn, right, at the same time, so it usually will not get stuck. It'll usually try to turn and move. If you call it gyro drive just distance, we'll just try to go the distance. It's going to try to turn the angle, but it also will back up or go forward depending on what you have. The trade-off here is the distance may not be accurate. Okay? There's another caution. If there is a large difference in the angle, the robot may turn and will in fact turn very fast to get to that angle. So you're going to have to experiment. Another way to do this is to use gyro drive by time. Okay? Notice here I have 100 speed, angle 45 for 1.5 seconds. Why would I have such a big number? Well, in this case, that particular one was used last year to push the windmill thing to drop the energy modules into the robot. You'll see that video. But 100 meant the wheels were turning really fast. I needed that to get as much push out of that as I could get out of it. And you'll see it kind of worked. But this is used to drive at a certain speed and angle over a specific amount of time. This is here to help you get out of jams, right? Again, if there's a large difference in the angle, the robot may turn too fast. Okay? Potentially, if you can, what I would do is back away using the by time a slow, using the same angle that it should be on, back away a little bit, and then you'll be good. And then you're clear and you go from there. And actually, believe it or not, it's been pretty accurate. Okay. So again, you're going to have to experiment. Okay. Spike gyro distance accuracy. This has to do with how far you're actually going. Okay. In the My Block init settings, we calculate the wheel circumference, pi times d. This tells us how far the wheel travels in one rotation. We then calculate how far we go in 1 degree. Now, we're going in inches, right? Because the calculation down there at the bottom, you'll see the bottom line, it says in 2.3, the 2.3 below represents the diameter of the wheel in inches. We can now accurately measure our course in inches. And what do we see? 2.3 times pi, right? And then down below that, we're calculating distance by degree, right? Now, why am I doing that? Because when a wheel turns, it gives me degrees, okay? It gives me degrees. I multiply. When I'm ready to start going forward, I actually reset my distance back to 0. And then my reference wheel, which is one of the things you're going to see, I reset that reference wheel back to 0, and then I drive. When I stop, I can say, okay, as I'm going, I can look at that wheel and say, what have I got? And it'll give me the degrees. I multiply distance per degree by degrees, and when that number gets to be greater than the distance I want to go, I stop. That's all there is to it. You can see it in the code. All right. Now, spike gyro distance accuracy. Now, some people complained that, hey, the thing's supposed to have encoders and all that. Again, it's a toy. It's not a military grade device. However, if done right, it is very accurate. Once you have the robot design done, it is time to start to dial in the distance accuracy. And you're going to do this and set it and never change it. On the competition mat, put down a measuring table. And you got to do it on the mat because that's where you're going to be. All right? Then you're going to write this program in the clean code file. Right? What is it going to do? It's going to turn off the pixels, basically shut off the display, call in its settings, which is going to set everything up. And then you're going to do gyro drive-by distance. You're going to try different speeds. 30 was a great speed for the robot I had, okay? 0 angle, so as soon as it starts up, it should be at a 0 angle, and it'll go straight, okay? And then you go your distance. You have to start trying at different distances. Short distances, most of the time, the accurate stuff you need is going to be short distances, 5 inches, 10 inches, 15 inches, okay? They were very accurate, okay? 30 inches was short by an inch, okay? And using slower speed will minimize wheel slip. If your short ones are too inaccurate, you change the circumference of the wheel value until you dial in your short ones, okay? Now, if you have one that's 20 or 30 or something, you know, the real short ones are what's important. The 30-inch may need to put a value of 31, but it is very repeatable now to 30 inches. Okay? That's the best we can do. All right. Please watch the videos. Good luck. Make mistakes. Learn. It is frustrating, but you're going to have a lot of fun, and you're going to understand how gyros work, and it's really cool. And I want to make sure when you get to your first engineering class, 101, and the professor's up there and he goes, does anybody know how a gyro works, or an IMU, inertial measurement unit? You stick your hand up and you go, absolutely, I used to build robots. That actually happened to one of my students, one of my kids who came through the program. Learn and have fun.